Hello everyone, this is Hating Tian. This video we are learning 1.3 solve trig equations. First, we need to know what is the graph of the sine, cosine, and tangent function, and also their reciprocal functions. For the sine function, it is the red curve here. You can see this curve is our sine function. And then if the output value or the y's value, all of the function, sine of x is equal to 1/2. So y's value is equal to 1/2. On my y-axis, here is 1/2. And here is 1. So when the y is equal to 1, we have a purple horizontal line. So all of these intersections or intercepts are the y equals 1/2. And what are their x value for this point? And x value is pi over 6. And this point is 5 pi over 6. So we have more points. For example, here, here, and other points. So we have infinity solutions for the x value. And if I'm looking for the x value in one full cycle, so I'm talking about the points here and points here. So these 2 points, they have the y's value 1/2, and the x value is pi over 6 and 5 pi over 6. You can also solve this question by using the unit circle. For example, first, the y's value for the sine of x is 1/2. And this is positive or negative value? Positive. So sine positive, they are in these 2 quadrants. And when, what is the x value when my sine x is equal to 1/2 in first quadrant? 30 degree. Or we can say this is pi over 6 because our interval of the x is reading measure, let's say pi over 6. Instead of 30 degree. And in my second quadrant, the reference angle is also pi over 6. But what is the actual angle? So the actual angle is starting from initial side and do the counterclockwise rotation. So in the second quadrant, it is pi minus pi over 6, which is 5 pi over 6. So we have 2 solutions. We can put the solution here. First one in first quadrant, pi over 6. In second quadrant, 5 pi over 6. You can use the image of the sine to find the x value. You can also use the unit circle to find what is the x value. All right, let's move on to see next example. This is a tricky one. So it's asking for the x value in one full cycle. And the given information is cosecant x is equal to 2. I have learned the graph of cosecant. We first graph the sine function. I need to use dashed curve. This is one full cycle of the sine. And the other cycles. And then we need to draw vertical lines. These are my vertical asymptotes. So the secant line is head to head or bump to bump. This is the cosecant function. But this question, we're not asking about the graph of the cosecant. We're solving for the x. We don't need to worry about the graph of cosecant. We can solve it from sine function because the reciprocal of cosecant is sine. So next step, I'm going to rewrite my equation into 1 over sine of x is equal to 2. And then we can flip both sides. One side is 1 over sine x, another side is 2 or 2 over 1. We can flip both sides. We rescue the sine x to the top. Sine of x is equal to 1/2. Now we are going all the way back to the example 1. Sine of x is equal to 1/2. Now we know that if we are using the unit circle, sine positive in these two quadrants. In first quadrant, sine of x equals 1/2. Then my angle is pi over 6 or 30 degree. In second quadrant, the reference angle is also pi over 6. The actual angle is 5 pi over 6. So we have two solutions, pi over 6 and 5 pi over 6. So that is the x in one full cycle from 0 to 2 pi. Okay, let's see example 3. Let's solve the x from this equation. In the previous example, we have only one variable. For example, we have one variable cosecant of x and one variable sine of x. Now we have tangent on both sides of the equation. Let's combine all the tangent x together and then solve for the x. So first, I want to move this one to another side. We can add the tangent x both sides. We're having 3 tangent x is equal to square root of 3 divided by 3. Isolate my tangent x. Square root of 3 over 3. Now let's solve for the x. I'm solving the x in one full cycle, and tangent is positive or negative. First, decide where is it, in which quadrant. Tangent positive. So A as TC, T is here. In these two quadrants, tangent is positive. So randomly draw a terminal side. In first quadrant, what is the x value for tangent? X is equal to square root of 3 over 3, pi over 6, or we can say 30 degree. So in first quadrant, x is equal to pi over 6. How about in third quadrant? Reference angle must be pi over 6. What is the actual angle from initial to the terminal here? In third quadrant, we say the x value is pi plus pi over 6. It is 7 pi over 6. How did I find 7 pi over 6? I need to combine pi and pi over 6. So pi is pi over 1 plus pi over 6. They do not have the same denominator. Multiply by 6 top and bottom. Enlarge top and bottom. So 6 pi over 6 plus pi over 6. They have the same denominator at the top, 7 pi over 6. So 7 pi over 6. So if you know how to combine them together, ignore this. All right, next question. Solve the higher degree. So this one, we can solve for the x like the previous example. We can isolate the cosine x. Okay, first method or way 2. Way 1. So way 1, like the previous example, we can isolate the variable cosine x. So we plus 1 both sides. We have 4 times cosine x squared is equal to 1 divided by 4. So cosine x squared is equal to 1 over 4. And then how to get rid of the squared? Let's take the square root of both sides. When I'm taking the square root, what should I do? Plus or minus sign. So cosine x is equal to positive or negative square root of 1 over 4. We need to square root the top, square root of the bottom. So cosine x is equal to 1 over 2, 1/2. Cosine x is equal to positive 1/2, or cosine x is equal to negative 1/2. So we solved for the cosine x. Then later we are solving for the x. Okay, and what is my another way solving for the cosine x? So here is a hint. I don't want to write too much things. So I see my function is 2 terms and equals 0. Can you factor it? So make it into the multiplication form, and then equal to 0. First factor is equal to 0. Second factor is equal to 0. Can you factor these two terms? Yes, we can factor it because it is a conjugate formula. First term is 2 times cosine x, all of them squared, minus 1, or we say minus 1 squared. So we have 2 times cosine x plus 1 times 2 times cosine x minus 1. And then each factor is equal to 0. We got the same solution. Cosine x is equal to 1/2, positive 1/2, and negative 1/2. Okay, so this is cosine x. Okay, let's move on. We are solving for the x, not cosine x. Let's keep moving. When the cosine x is equal to 1/2, cosine is positive, so x is in which two quadrants? First one and the fourth quadrant, because A, S, T, C, cosine in fourth quadrant is positive. So in first quadrant, the cosine x is equal to 1/2. X must be pi over 3 or 60 degrees. And then in fourth quadrant, we must have the same reference angle here and here. So in fourth quadrant, this reference angle is pi over 3. What is the actual angle? So the actual angle is starting from initial all the way here. So we can use 2 pi minus pi over 3. So the x value is pi over 3 and 5 pi over 3. We got two solutions from the cosine x is equal to positive 1/2. How about cosine x is equal to negative 1/2? Cosine negative in which two quadrants? Oh, these two quadrants. And for cosine x in fourth quadrant, in second and third quadrant, we can only look at the positive value 1/2. So it shows us reference angle must be pi over 3, because cosine x is equal to 1/2 or positive or negative 1/2. That means the reference angle of the x is pi over 3 or 60 degrees. Okay. If I know the reference angle, then the actual angle, what is the actual angle? It is the angle from here to here. It is pi minus pi over 3. And the angle in third quadrant. So this is also our reference angle, pi over 3. So the angle in third quadrant is pi plus pi over 3. So another one is pi plus pi over 3. Combine them together, we are having 2 pi over 3 and 4 pi over 3. Totally, we have 4 solutions. So we have 2 here and 2 here. All right, so let's see number 5. Okay, number 5, how to isolate the sine x, or how to solve the sine x. This one, we have 2 terms. We can factor it, make it into the factor form, and each factor is equal to 0. We can solve for the sine x. Okay, how to factor it? These 2 terms has the GCF, which is 3 sine x. Let's factor out the GCF, 3 sine x. The leftover is 2 sine x minus 1 is equal to 0. Then we say 3 times sine x is equal to 0, or 2 times sine x minus 1, second factor, is equal to 0. So from the first equation, we say divided by 3 both sides, sine x is equal to 0. And then solve for the x. in which quadrant and what is the value of the x? My sine is equal to 0. Okay, do you remember? We have unit circle. Any point on the unit circle must have the coordinate cosine x or cosine theta comma sine theta. My sine theta is equal to 0. Oh, that means y's value is equal to 0. Where is the y's value is equal to 0? Here. And here, let's use different color. So this point and this point, they have the sine theta, or we say y's value is equal to 0. Then my x value of the point here, the x value for the angle here is 0. And the x value, the angle value of here is pi. So I got two solutions of the x, 0 and pi. Let's solve another equation. So 2 times sine x minus 1. So let's have more space here. Minus 1 is equal to 0. Isolate the sine x plus 1 both sides. We have 2 sine x is equal to 1. Divided by 2, sine x is equal to 1/2. So sine is positive. We are looking for the sine. We are looking for the x in one full cycle. Okay, sine value positive. I need to have my x value in these two quadrants. And then in first quadrant, the reference angle, or we say the angle here, must be pi over 6. Or you say 30 degree. And in second quadrant, they have the same reference angle. The extra angle is from here to here. It is pi minus pi over 6. It is 5 pi over 6. We have 4 solutions. You can list them in the set notation. 0, pi, pi over 6, 5 pi over 6. So if the question says, order your solution from the small to big, you can list them like 0, pi over 6, 5 pi over 6, and pi. So keep them the order from the small to big. Okay, next example. How to solve for the x then in this equation? Can we factor it? Yes, we can, because we have 3 terms. We can use AC method or crisscross method. Some of you say, I didn't see the AC method or how to use the crisscross method or quadratic equation, quadratic formula. So if I have this 2 times y squared plus 7y minus 4. Minus 4 is equal to 0. Do you know how to factor it? Yes, we have learned that we can use AC method. A is 2, C is negative 4. If you don't know what is the AC or AM method, go back to the 1.1. We have reviewed what is the quadratic equation, factor the quadratic equation or trinomial. So A times C is negative 8. Find 2 factors. Addition make a 7. So we have negative 1 and positive 8. Then we can break down the middle term 7y to be minus y plus 8. Y plus 8y minus 4. And we have 2y squared in front. Do the group factoring. First 2, last 2. Then we can factor our quadratic equation. But this question, you see 2 times sine x squared plus 7 sine x minus 4. Okay, first variable, we're having sine x squared. It is the squared. Middle variable is sine x. Oh, that means I can use a substitution method to replace my sine x. So by y or by any other by any other variable. So let's say, let the middle variable sine x is equal to y. Then the sine x squared is equal to y squared. I square both sides. Then replace my sine x squared with y. 2y squared plus 7y minus 4 is equal to 0. If I'm using the AC method, a is 2, c is negative 4. Then we have a times c, negative 8. Find two factors. Addition make us 7. So we have 1 times 8. 1 is negative. So next step is break down the 7y. We have 2y squared minus y plus 8y minus 4 is equal to 0. The group factoring, factor out the y, we have 2y minus 1. And then factor out the 4, we have 2y minus 1 is equal to 0. So factor out 2y minus 1, and then multiply by y plus 4. Okay, each factor is equal to their 0. 2y minus 1 is equal to 0. Y plus 4 is equal to 0. So solve for the y is equal to positive 1/2. Solve for the y, negative 4. So what is the y? At the beginning of my question, my solution, I have assume that sine x is equal to y. So y is sine of x, 1/2. And then sine of x is also equal to negative 4. For the first equation, sine x is equal to 1/2. So sine is positive in these two quadrants. I can find my angle. So x is equal to pi over 6 or 5 pi over 6 because the x in radian measure. Okay, so I got two solutions. From the second equation, sine of x is equal to negative 4. We have learned that sine of x, it doesn't matter what is the x, it's bounced between negative 1 and positive 1. You cannot equal to negative 4. It's too small. It must be between negative 1 and positive 1. So if I have sine of x is equal to negative 4, we have no solution for this equation. So we only have two solutions, pi over 6 and 5 pi over 6. Okay, let's see next part. Use identities to solve trig functions. If we have secant x squared minus tangent x is equal to 1. So like previous example, we say convert it to the zero product property and then find the x value from the new equation. Can you factor it? I cannot because I didn't see any common factor, or I cannot use AC or AI method to factor it. So we can relate the secant x and the tangent x. So do you still remember the Pythagorean theorem? We have three Pythagorean theorem. Sine x squared plus cosine x squared is equal to 1. And also we have tangent x squared plus 1 is equal to secant x squared. And 1 plus cotangent x squared is equal to cosecant x squared. Okay, the middle one, we can replace the secant by the tangent x squared plus 1. So we replace this one with tangent x squared plus 1, then minus tangent x is equal to 1. So if we want to factor it, and one side of the equation is 0, so we need to make a 0 on the right-hand side. Let's minus 1 both sides. So this one cancelled. We have tangent x squared minus tangent x is equal to 0. Factor out the tangent x. We have tangent x minus 1 is equal to 0. So first factor is equal to 0. Second factor is equal to 0. We can solve for the x. So here is tangent x is equal to 1. For the tangent x is equal to 0, what is the x value? So it is 0, right? We have learned this before. Or we have learned for tangent, for on the unit circle, and any point is cosine comma sine, and tangent, we say theta, is equal to sine over cosine, or you can also say y over x. So on the top, if it is 0, then the division is 0. That means y's value or the sine value is 0. This point, the y's value is 0, and this point also y's value is 0. So we have 2x solution. Angle is 0 or pi. And from second equation, okay, second equation, tangent x is positive or negative? Positive. So my x is in these two quadrants. In first quadrant, tangent x is equal to 0. Then the angle must be pi over 4. In fourth quadrant, we also have the tangent x is equal to 0. So the reference angle must be pi over 4. So x is equal to pi over 4 in first quadrant. And then x is equal to what? Find the angle here. We are using pi plus pi over 4. It is 5 pi over 4. We have 4 solutions. 0, pi over 4, pi, 5 pi over 4. Ascending order. All right, we solved the x. Let's see number 8 and number 9. Read the question. Okay, solve the x on the interval from 0 to 2 pi. So we have 2 times sine x squared minus cosine 2x. Okay, so it's very interesting because here we have 2x. I'm solving for the x, how to get rid of the 2x. Excuse me. Double angle formula. So for the double angle formula, if we have the, cosine x squared plus, I'm saying double angle formula, I'm saying cosine. So cosine 2x. Cosine 2x has 3 formulas. First one is cosine x squared minus sine x squared. Also is equal to 2 times cosine x squared minus 1. Also equals 1 minus 2 times sine x squared. Okay. Now, which method I'm using? This one, I can convert my cosine 2x to be something sine related. It's here, right? Okay. Let me see if I didn't copy the wrong question from my lecture notes. There's no mistake. So let's replace the cosine 2x with the formula 1 minus 2 times sine x squared. So we have 2 times sine. Okay, it's not working. 2 times sine x squared minus parentheses 1 minus 2 sine x squared is equal to 0. And then let's clear the parentheses. 2 sine x squared minus 1 plus 2 sine x squared is equal to 0. Let's combine like terms. We have 4 sine x squared minus 1 is equal to 0 plus 1 both sides. 4 sine x squared is equal to 1 divided by 4. Sine x squared is equal to 1/4. Let's take a square root of both sides. Sine of x is equal to positive or negative square root of 1/4. We square root to the top, square root to the bottom is positive or negative 1/2 or 1/2. And then we need some space here. Solve for the x. The first equation is sine x is equal to 1/2. Second equation is sine of x is equal to negative 1/2. For the first one, sine x positive in these two quadrants, first and second. The reference angle is pi over 6. In second quadrant, this angle must be 5 pi over 6 because we use pi minus pi over 6. Okay, so another solution is 5 pi over 6. And then the second equation, sine x is negative. We are having angle in third and fourth quadrant, and they all have the same reference angle, which is pi over 6, because the value of the sine equals 1/2. Reference angle must be pi over 6, or 30 degrees. Okay, in third quadrant, the angle x must be pi plus pi over 6. And in fourth quadrant, so this angle equals 2 pi minus pi over 6. So the x is equal to 7 pi over 6 and 11 pi over 6. So we have 4 solutions of the x. Okay, let's move on to see the number 9. So solve for the x on the interval from 0 degree to 360 degree. Now it is the degree measure. And then let's read the question. Cosine 2x plus 3 is equal to 5 cosine x. Oh, we got 2x again. What should I do? And also we have cosine x. We need to, we must convert them to be cosine x, or convert both of them to be cosine 2x. We cannot have the input here is 2x, or another side is input is x. All right, let's use double angle formula to convert the cosine 2x to be the cosine x. So we have 3 formulas. So here we have 3 formulas. Oh, I highlighted the wrong place. Where is my formula? Did I erase it? Yes, I erased it. We can rewrite it again. So the 3 formulas, they are cosine 2x is equal to cosine x squared minus sine x squared, and also equals 2 times cosine x squared minus 1, also equals 1 minus 2 cosine x. Sine x squared. Now I can convert my cosine 2x to the 2 times cosine x squared minus 1. Okay, let's rewrite the cosine 2x. It is 1 minus 2 times, I'm choosing the second formula. So 2 times cosine x squared minus 1 plus 3 is equal to 5 cosine x. And then move everybody together. We have 2 times cosine x squared minus 5 cosine x. We can minus 5 cosine x both sides. Minus 1 plus 3, it is plus 2. Is equal to 0. We can use substitution method to factor it. So we can also use crisscross method, because the previous example I used the substitution method. And this one, if I'm using crisscross method, we have find the factor of 2, list them vertically. We only have 1 times 2 is 2. And the last term, 2, find the factor of 2. 2 times 1. Do the crisscross multiplication. 1 times 1, 2 times 2. 2 times 2 is 4. So if I add them together, we're getting positive 5. Something wrong. I cannot get a positive 5. I'm making a negative 5. So your 2 factors of 2 must be both negative. Then do the multiplication. Negative 1 plus negative 4. Then we have negative 5. Yes, we made it. So we write them horizontally. So 1 represents 1 cosine x. So in the parentheses, we have cosine x minus 2. Multiply by 2 represent the coefficient of cosine x. 2 cosine x minus 1 is equal to 0. And then we can solve for the x. From the first equation, we have cosine x is equal to, minus 2 is equal to 0. 2 times cosine x is minus 1 is equal to 0. So solve for the cosine x plus 2 both sides. Cosine x is equal to 2, but we learned all of the sine cosine. They are bounced, the value bounced between -1 and +1. We cannot have a 2, that's too big. That means we have no solutions here. But on our another equation, we can solve for the x. Solve for the cosine first. Plus 1 both sides. 2 times cosine x is equal to 1. Divided by 2, cosine x is equal to +1/2. Now we are looking for the x in one full cycle and the degree measure. So cosine positive is in first and the fourth quadrant. So cosine is equal to 1/2. So the x value is 60 degrees or pi over 3. In fourth quadrant, they have the same reference angle. So reference angle is 60. So x in the first quadrant is 60 degrees. And in fourth quadrant, we can use one full cycle, 360 degree minus 60 degree. So we have two solutions, 60 degree and 300 degree. We got two solutions. Okay, let's see examples. Example 10. So in my equation, the input area is not single x. It is something else. It is 2x, 3x, 1/2 x, 4x, 5x. So how to solve for the x? What is the meaning of 4x? That is the horizontal shrinking or stretching, right? So 4 times x, am I going to stretch horizontally? No, x is opposite. We are shrinking it horizontally. So before one full cycle is from 0 to 2 pi, we're going to have my graph like this. But now I shrink it horizontally. My graph will be super busy. So we are having the blue graph like this. All right. The y's value, the output value is 1/2. That means, here is 1/2. Y's value 1/2. I draw a horizontal line. All of the intercepts, they are the y's value 1/2, and then we can find the x value. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 solutions from the graph. Okay. So let's find what is the x value. So now we solved the 8 values. We see the 8 values. We count it on the graph. But what is the exact value of the x? Let's see the example 11. Okay, first we need to isolate not isolate. So before we are solving for the x, we should find the interval of the x. So we want to solve for the x. At the end of the solution, we have the x. And the x value must bounce between, axis belong to 0 to 360 degree. It's bounced between 0 and 360. But in my example here, we have 2x. So we want to solve the 2x first. We need to find what is the adjusted interval. So the x is bounced between 0 and 360 degree. And then solving for the 2x. So we need to multiply by 2 everywhere. So 2 times 2 times 2. So we are having 2x is also between 0 degree, but another side increased, multiplied by 2, 720 degree. So first, let's find the adjusted interval. And the second, let's solve for the sine 2x. So isolate the sine 2x divided by -2 both sides. So sine 2x is equal to negative square root of 2 over 2. So we need to solve for the 2x first. So 2x, they are combined together. So this angle 2x make my sine negative. Where is the angle 2x? Oh, sine is negative. I must have my angle in third and the fourth quadrant. Okay, so what is the theta's value if I have the sine value square root of 2 over 2? If I see this, reference angle of theta is pi over 4 or 45 degree. If I have plus or minus square root 2 over 2, the reference angle of theta, they are all 45 degree or pi over 4. Okay, that means we're having reference angle here is 45 degree and here is 45 degree. So my 2x is equal to 180 degree plus 45 degree is the angle in third quadrant. How about in fourth quadrant? We're using 360 minus 45 degree. And then we're having 2x is equal to 225 degree and 315 degree. Can I say I have only two solutions? No, because 2x adjusted interval is between 0 and 720. That's 2 revolution. If I have the terminal side here, and then I can add 1 full cycle plus 360. We're having the same terminal side. So based on the first angle, so 225, we can plus 360. And based on the 315 is in the fourth quadrant, I add 1 full cycle. I'm having 315 plus 360 degree. So 2x is equal to 225 degree and 315 degree and 585 degrees, and then this is 675 degree. And now we have all of the angle in 2 revolutions. We can solve for the x. So divided by 2, everybody. X is equal to 225 over 2. It is 112.5 degree. 315 divided by 2. It is 157.5 degree. And 585 degree divided by 2. It is 292.5 degree. And 675 divided by 2, 337.5. Solving for the x, in this equation, first I found the adjusted interval. From the beginning, I know x must be between 0 and 360 degree. But in my expression, I'm not only solving for the x. Let's solve the 2x first. So we need to have the interval of the 2x. So we can double 3 parts. The 2x is between 0 degree and 720 degree. And then next step, we can solve for the 2x first. Then divided by 2, I can get my x value. So we have 4 values. Let's see number 12. Given this equation, find all the values of x on the interval 0 to 2 pi. So solving these 2 questions, my sine is not sine x. It is sine of something else. It is 2x, 3x, 4x, half x, or x over 4. We can find the adjusted interval first. So let's see, what is the adjusted interval of the x over 2? So x is between, so from the given information, x is between 2 pi. Now the half x, divide by 2 here, divide by 2 here, divide by 2 here. So my x over 2 is between 0, this is reading measure, and pi. Okay, make it clear. Let's take away the 2 here. Okay, let's find the the x over 2 between 0 and pi, which is the first two quadrant 1 and quadrant 2. The equation is square root of 2 sine half x over 2 minus 1 is equal to 0. Isolate the sine x over 2 plus 1 both sides. Square root 2 sine x over 2 is equal to 1 divided by square root of 2 both sides. Sine x over 2 is equal to 1 over square root of 2. I need to rationalize this this fraction multiplied by square root of 2 top and bottom. We're having square root of 2 over 2. So if my sine sine x over 2 is square root of 2 over 2, let me ask you, sine positive or negative? Positive in these two quadrants. So also I need to see where is my x over 2. It's also in these two quadrants. Yes. So these two angles, they are the value of x over 2. So in first quadrant, okay, sine x over 2 is equal to square root of 2 over 2. So in first quadrant, x over 2 is equal to pi over 4 or 45 degrees. In second quadrant, so what is the angle here? I know we have the reference angle, pi over 4. So pi minus pi over 4 is 3 pi over 4. So 3 pi over 4, that's all. I cannot have any other angles because my angle is bounced between 0 and pi. First two quadrant. Now we are solving for the x. We can multiply by 2 to get rid of the bottom 2 here. So multiply by 2, I have the x. So 2 times pi over 4, it is pi over 2. So we can just say half pi. Use the pi over 4 times 2. And then 3 pi over 4 times 2, it is 3 pi over 2. We have two solutions. They are half pi and 3 pi over 2. Okay, we are done. We are done for the 1.3. If you have any question, please let me know. Bye. See you next video. Bye-bye.